In this video for section 2.6, we're going to talk some more about the domain of a function. When we're finding the domain, we need to exclude values that would make the denominator of the fraction equal to 0, or values that would result in taking the square root of a negative number. So for example, if I have the function f of x equals 1 over x minus 3. If I plug in 3 for x, that would make my denominator equal to 0. And so my domain using set notation is written like this: x such that x is not equal to 3. Now to write that using interval notation, we're going to write it like this. So we have negative infinity up to 3, that interval, with parentheses around both, because we always have parentheses around infinities, and we have a parenthesis around the 3 because we are not including 3. In fact, we specifically do not want to have 3 in our interval, so we use a parenthesis. This U here stands for union, and you can think of that as meaning or putting these two pieces together to make the total domain. So the domain also includes from 3 to infinity, not including 3, so we have parenthesis around the 3. So basically, this is putting these two pieces together so that the value of 3 is not going to be part of either piece. So the value of 3 is excluded. So now we're going to look at a problem with a square root. If we consider the function g of x equals square root of x minus 3. The smallest value that we can plug in for x is 3. If we plug in 3 for x, we have 3 minus 3, which is 0, and the square root of 0 is 0. If we plug in anything smaller than 3, then this under the square root will be negative, and we would be taking the square root of a negative number, which is not allowed. So what we're going to do is set whatever's under the square root sign greater than or equal to 0. So in this case, it will be x minus 3 greater than or equal to 0, and solving for x gives us x greater than or equal to 3 by adding 3 to both sides. So using interval notation, the way that I would write that is like this. X is greater than or equal to 3 means that 3 is included because of the equal to, so I use a square bracket around 3, and then up to infinity, because numbers bigger than 3 will be from 3 on up, and then parenthesis, of course, around the infinity. So this would be the domain. So we're going to do example 1 from the textbook. First one, part A, is f of x equals x squared minus 7x. So the two things that we're looking for are fractions and square roots. We don't have either one here, so there are no restrictions on the domain, which means that the domain goes from negative infinity to positive infinity. For part B, this time we have a fraction. So when we have a fraction, x squared minus 2x minus 3, I need to figure out what values of x would make this equal to 0, because that's what's not allowed. So in order to find that, I need to factor it. So x minus 3 times x plus 1 would be the factored form, two numbers that multiply to negative 3 and add to negative 2. So setting each factor equal to 0 and solving gives me a value of x equals 3 and x equals negative 1. Now remember, these aren't solutions. These are values that I cannot plug in for x because they would result in 0 in the denominator. So the way that I would write this in interval notation is I'm going to go kind of similar to the first one. I'm trying to exclude the value of negative 1. So to exclude the value of negative 1, I need to go from negative infinity to negative 1, and then do a union and put negative 1 on the other side, and use parentheses around both. Now, when I'm doing this, though, I have two values that are not allowed. So I need to do that for two places. Since negative 1 is the smaller value, that's going to go first, and 3 is going to go second. So I can go from negative infinity to negative 1. I can go from negative 1 to positive 3. And I can go from 3 to infinity. So those 3 pieces all together make up the entire domain. Part C, this time I have a square root. So what I'm going to do is set what's under the square root, 3x plus 12 in this case, greater than or equal to 0, and solve. So I would subtract 12 from both sides, and then divide, and that gives me x is greater than or equal to -4. Now to put this into an interval, this means it's going to be -4 with a square bracket, and everything greater than that means that -4 is the smallest value, so it can go from -4 up to infinity, parentheses around the infinity. Now for part D, I have 2 things going on here. I also have a square root in this one, and I have a fraction. So what I need to do here, since I have both things, is that what's in the denominator has to be greater than or equal to 0 because of the square root, but it can't be equal to 0 because it's a fraction. So instead of setting the square root, what's under the square root, greater than or equal to 0, I'm going to do just greater than 0. So we can't have 0 in the denominator. So, solving this inequality, I would subtract 14 from both sides. Now, there's a rule here that I'm going to have to use that you may remember, and it's that when you divide by a negative, the inequality needs to flip. So since I'm dividing by -2, this is going to flip to less than. -14 divided by -2 is going to be +7. So that's the other key here, is to flip. So, writing this in an interval, if x is less than 7, that means 7 is the biggest number, and so my interval would go from -infinity up to 7. Use a parenthesis around the -infinity and a parenthesis around the 7 because it can't be equal to 7. It's strictly less than. So this would be the interval notation for this domain. So next, you should look at checkpoint problem number 1. Do these in your notes, check your answer, and then move on to the homework.